Hi everyone and welcome back to PrepFusion. I am Anish and today we will start with the lecture 4 of the two-port networks. So today will be the final lecture where we will discuss about the interconnection of two-port networks and two-port networks for transformer and gyrators. Okay, this is a small topic. This is the main topic that we will discuss today. So let's first discuss one by one. So two-port networks can be interconnected to form complex systems. So there is a very huge network, right? You can simplify. So like what do I mean by interconnection? So let's say this is the network. Okay, very small thing I'm telling you. This is one network. Okay, so you can simplify this, right? This two are in series, these two are in parallel. So you can write it like this will be some r1, this will be some r2, the parallel combination. So this is how you simplify normal resistive networks. So in two ports as well we can simplify, because if I know the two port parameters of network A and network B, will I be able to write the two port parameters if they are connected like this? Okay, that is my main purpose. Without going into the equations, I mean solving the circuit, without solving the circuit, just with the help of equations of an A and an B, two port parameters of network A and network B, will I be able to solve it? Okay, that is the important point. So in series connection, right? In series connection, what happens? Series connection means what? Series connection, if two networks are connected in series, N A and N B are connected in series, what does it actually mean? N A and N B are connected in series. It actually means that the current is same. Current through network NA and current through network NB will be same. That is the port 1 current of network NA and port 1 current of network NB should be same. The port 2 current of network NA and port 2 current of network NB should be same. Okay. So is it the case? Is it the case here? So I think it is the case, right? So here I1 current is going in. This is the port current of the whole network. This is the port current of the whole network. So I1 current is going in here. I1 current is going in, and this is the port 1 current of network NA. I1. So I will write the definition, right? I1 is the I1 is the port current of combination of NA network. So combination of NA and NB. I2 same, right? I2 is the port 2. This is the port 1 current. I2 is the port 1 current which is combination, which is a combination port 1 current which is a combination of NA and NB. Okay, same thing for I2 as well. Same thing for I2 as well. I2 is the port 2 current which is combination of NA and NB. Okay, so next, what about the individual current? So I1A is the port 1 current of network NA, I1B is the port 1 current of NB, I2A B is the port 2 current of network B, I2A is the port 2 current of network A. So if I notice that my I1 and I1A are same, right? So I1 and I1A is the same. And what is the property of a port? Whatever current goes into the one of the terminals of the port should come out of the other terminal. So this also will be equals to what? This also will be equals to I1A. Now this is right interconnected to the input of the port B, I mean network B, right? So basically your I1A and I1B are same, which is equals to I1A, and same current is coming out here. I1B should come out here, right? So this is I1B, and this current is what? This is the overall port of the network. So whatever current comes in, same current should go out. So this will be I1. So basically my I1B is also equals to I1, right? So ultimately what is the equation? Ultimate equation is I1 is equals to I1A equals to I1B. This is the ultimate equation. And this basically means they are in series. If the currents are same between two networks, that means it is in series. Same for resistor, right? Same for resistor. If the currents across two resistor are same, that means they are in series. Okay. The voltage are getting added. So what is my V1? If I notice, if I apply a KVL in this loop, okay, what will be the voltage? Voltage will be minus V1 plus V1A plus V1B equals to 0. So minus V1 plus V1A plus V1B equals to 0. So V1 will be equals to V1A plus V1B. Okay, so this is what my voltage V1 is equals to. This is what my voltage V1 is equals to. Now, how is this valid? Like how is this getting formed, right? Basically, if two networks are in series, that means my Z parameters will be added. So let me prove it to you. Let me prove it to you how it is possible. Okay, so let me write the Z parameters for network A and network B. Let me write the equations. So for network A, the equations are as follows: that V1A will be equals to Z11A plus Z11A plus I1A plus Z12A I2A V2A equals to Z21A equals to I1A plus Z22A equals to I2A. Okay, so from here, this is the individual equations of the network A. What about the network B? Everything will just be changed to B. That's it. Everything else remains same. This will be gone. Everything will be changed to B. That's it. So one thing I know is that my I1A is equals to I1B equals to I1. So I can change all this, right? I can simply convert all this to I1 only. Correct. Same here as well. This will be B. Sorry, this will be B, right? This will be B. This will be I1 only. Sorry, this will be there. This will be I1 only. This will be I2 only. Okay, fine. So now, what is another equation? Another equation is V1 is equals to V1A plus V1B. So what if I add these two voltage? So same equation you can write on the output KVL as well, that your V2 will be equals to V2 will be equals to V2A plus V2B. Okay, V2 will be equals to V2A plus V2B. So if I add, let's say 1, this is 2, this is 3, and this is 4. So if I add equation 1 and equation 2, what will I get? It will be V1A plus V1B. What is it equals to? It is equals to V1, correct? So on the left hand side I will have V1. On the right hand side it will be Z11A. I1 is common, right? I1 is common, so it will be Z11A plus Z11B. Z11A plus Z11B into I1. Same for the other equation as well. Z12A plus Z12B into I2 equals to Z21A plus Z21B into I1 plus Z22A plus Z22B into I2. Okay, so that is the case here. Now if you understand this individually, that individually my matrix was Z11, like ZA matrix was Z11 A, Z12 A, Z21 A, Z22 B. So simply, right, they are simply getting added. So basically I can simply write that my, like this I can write in matrix format. This will be equals to what? This will be Z11 A, Z11, sorry, Z12 A, Z21 A, Z22 A plus this will be Z11B, Z212B, 21B, Z22B. Okay, so if I add these two matrix, this will be ZA plus ZB. Okay, so this will be the answer for this particular like for this particular derivation. So I have, you have understood why it is simply the sum of the two Z parameter matrices. Yeah, I am sorry for interrupting the class. Like, I hope you can see the address has changed. Basically, like today was this, like t-shirts were supposed to be get delivered, so I was super excited. So I thought like, okay, let's break the class and like let's change the attire and record with this. So that's why, like, finally we have our own t-shirts and all those things. So yeah, that's why I'm sorry for interrupting the class. Okay, so yeah, let's restart basically. So I was discussing here, right? I had this Z parameters where Z parameters are basically addition of two. So like I have proven to you, right? If I add these two matrix, it will be Z11 plus Z11B in the element 1. Element 2 position will be Z12A plus Z12B, and so on, right? And so on. Okay, so I hope now I have proven to you why in series Z parameters will get added. Okay, so yeah, yeah, that was about it, about the Z parameters. Now like one important key point I wanted to mention here, that when will the parameters be added. So one key point I wanted to mention, one key point I wanted to mention, when will the parameters be added. The parameters will be added, the two port parameters, two port network matrix parameter matrix can be added, can be simply added, can be simply added, simply added if, simply added if the independent variables are same in the two networks. If the independent variables are same in both the networks. What do I mean by it? Both the networks. So here, right, have I written one thing? So I actually, I'm sorry, I forgot to write one thing, that your I2 is also same as I2A equals to I2B. Okay, that also I forgot. I think, yeah, I forgot to write. Yeah, I have written it here, right? So it is simply equals to I2, correct? So these are the two equations here. So here, right, what are the independent variables for a Z parameter? The independent variables are I1 and I2, right? Currents are my independent variables. So that is why I'm telling you that, okay, something, let this, right, I have to reduce the size. Yeah, that is why I am telling you that if the independent variables are same, then the matrix can be simply added. Why? Because if I'm adding these two values, what is happening? I1A is same as I1B. So simple, the elements are individually getting added. So that's why they need to be equal. Okay. So if the independent variables are equal, then there will be simple matrix addition. There will be simple matrix addition. Okay. This is one key point that we will see in the next derivation as well. Okay. We will see in the next derivation as well in the parallel connection. So in the parallel connection, mostly things will be same. Okay. Let me just mark this, and this will be the Z parameter. Yeah, mostly things will be same. Just here, right? I will go a bit quick now. So currents are different here. That is fine. But if I notice the voltage of port 1 is same as, like, these points is same, right? So V1 is same as V1A and V1 is same as V1B. Okay. So these are basically same. These are basically same. So I can say V1 is equals to V1A equals to V1B. Okay. And same for the V2 port as well. So V2 is same as V2A and V2B. V2 equals to V2A equals to V2B. Okay. So basically now here, what are my independent variables? Independent variables, like, which variables are same? V1 and V2. So in which kind of parameter the independent variables are V1 and V2? In the Y parameter. In the Y parameter, V1 and V2 are same. Okay. So in the Y parameter, V1 and V2 are same. So hence I can directly say my Y parameter matrix will be added. I will prove it to you as well. Will be added. Now I will do a bit of shortcut. What kind of shortcut? So I'll just copy the previous thing. I will change everything to Y. Okay. So I hope you will not be angry in this thing. So my voltages are same. What about the currents? So if I notice the currents, right? Currents I1 port current here, it is getting divided into two values. One is going to I1A, another one is going to I1B. So again, if I see, this current should be I1. This is I1B, this is I1, sorry, this is I1A, this is I1B. So again, ultimately my I1 is the addition of I1A plus I1B. It is just the opposite in the previous case, right? It was voltage in the previous case, now it is current. And my I2 is the sum, if you see, my I2 is the sum of I2A and I1B. Okay. So it will be I2A plus I2B. Okay. So this is my current basically. So now what I can say is, so this is the case, right? So I have to replace everything basically. So this, all of this will be Y, and this will not be Z. All of this will be Y. So first I will change all of this to Y. So it is exactly ditto, same process as the previous one. Just the difference here is that this will be I1. Okay. And this will be I2A, and this will be V. That is the difference. This Z will get cancelled basically. So this V will be here. Okay. So all of this also we can delete basically. So like, I'm just writing the Y parameter equation. So if I write the Y parameter equation, this will be Y11 V1A Y12 V2A, right? I hope you remember the Y parameter equation. This will be Y21A V1A, this will be Y22A V2A, this will be this will be I, this will be I, this will be I, this will be also I, right? I2B, I1B, I. So this will be I1B will be equals to what? I1B will be equals to Y11B into V1B, and your Y12B will be it will be Y12, this will be V2B, V2b, this will be Y21, this will be V1b, this will be Y22, this will be V2b, this will be Y11b, this will be V1b basically, this will be Y12, this will be V2. Okay, so the difference is now, right, what I have told you, that V1b equals to V1, correct? V1b equals to V1, V1a is equals to V1. So here this will be changed to Y11 into V1 only. This will also be changed to V2, Y12 into V2, Y12a into V2. This will be Y21a into V1, Y22a into V2. Here also same thing, Y21a into V1 and this will be Y22b into V2. Okay. So this was basically the equations. Now again the same thing, right? I think in the previous equation, yeah, this should be B actually. My bad, this should be B. So basically now if I add everything up, right? If I add equation, same process I will follow. If I add equation 1 and 3, what will I get? I will simply get my V1. Sorry, this is not V, right? Sorry. This is not V. This is I1A and I2A. So I1A plus I2A. What is I1A plus I2A? I1A plus I2A is simply not I2. I1A plus I1B is simply equals to I1, right? This I have written over here. So that's why it will be equals to I1, which will be equals to the series combination of admittances. So admittances are getting added. Okay, it is not series combination, it is parallel combination, because the admittances are getting added. Inverse of impedance is getting added, not impedance, right? So that's why it is the parallel combination. So this will be Y 11a plus Y11b into V1 plus Y12a plus Y12b into V2. I2 equals to Y, like same thing, right? Now if I add equation 2 and equation 4, Y 21a plus Y21b V1 plus Y22a plus Y22b V2. Okay, so these are my currents basically. This is my current I1 and this is my current I2, and this is how you write the Y parameters. Okay, I hope you have understood this basic point. So yeah, that's how you write a parallel combination. So ultimately what is happening? Ultimately your Y matrix of the overall network will be the matrix sum of Ya plus Yb, individual sum of the matrices. So this happens when it is parallel combination. Okay, I don't think I have to like describe this even more deeper, because I think it is clear. Now what is series parallel? Series parallel means the input side is in series, output side is in parallel. So this is the input side and this is the output side. So this is the case for a series parallel basically. So the input side is in series and the output side is in parallel. So input side is in series, right? Input side is in series. So if input size is in series, that means what? Basically the voltage will get added and the currents will be same. So here, right, I1 current is same as I1A. This is I1A current outgoing and this is same as I1B, and again outgoing current I1B is same as I1 only. Okay, but on the other side, on the output port, if I observe that here, right, I2 current is actually getting divided in I1, I2A and I2B. So it is not series, it is parallel. Why? Because V2 is connected across this V2A, also across this V2B. So that's why it is a parallel connection. So I can directly say on the input side that my I1 equals to I1A equals to I1B, okay, and my V1 equals to V1A plus V1B. Okay, so basically if I just use the KVL, what about the output side? In the output side, if I write the equations in the output side, this will be what, like V2 is equals to V2A equals to V2B. So V2 equals to V2A equals to V2B, and my I2 is equals to summation of I2 plus I2B. So I2 equals to I2A plus I2B. So yeah, this is the like cases here. So like what you can do now, check what are my which independent variables are same. So on the input side, my current I1 is same. On the output side, like same variables. On the output side, my V2 is same. Okay, my V2 is same. So do you remember which parameter it was? It was the H parameter. It was the H parameter. Okay, so we will of course I have to write down the equations, so it will be hectic. So I have to copy this whole thing again. That will be very hectic for me. Okay, output side, I have to copy this whole thing again. So if I copy this whole thing, and I have to write the H parameter equations, right? So I will write the H parameter equations. So all of this will get deleted. In the input side, it will be V1 only, right? Not V1, sorry, it will be I1 only. Okay, it will be I1, and the output side it will be V2. Okay, V2 we don't have to delete. So this only, this much we have to delete. Okay. 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 So this will be V1A basically is equals to H11, that is equals to I1A. This will be I1. This will be H21, that is my I2. Okay. This will be H22. This will be H12A. Now what I can write is that V1A in the input side, V1A is equals to H11A equals to I1, right? Because I1A and I1 are same. I1A and I1 are same, and I can say that V2A and V2 are same, right? V2A and V2 are same. Why? Because in the output side I have told you V2A and V2 are same. So V2A and V2 will be same in this case. Okay, this is I2A, this is H21A, and this is H22. Okay, so same here as well. So this will be V1B, that will be H11B into I1B, and this will be H12B, this will be V2B, this will be I2B equals to H21B. This will be H22B. Okay, in the previous thing as also I forgot to write B here, I think. This will be B, Y22, this also I think will be B, right? I forgot to write, I think. Just this will be B. Yeah. So this will be V1B, this will be I2B, this will be H11B into I1, because I1b and I1 are same. I1b and I1 are same, and this will be H1 to B, because V2b and V2 are same. If you see, V2b and V2 are same. Okay, same here as well. H21b, this will be I1, this will be H22b, this will be V2. Now what you do, same condition, right? Same thing, that I will just add the two. If I add 1 and 3, what is happening? If I add 1 and 3, basically V1a plus V1b. What is V1a plus V1b? It is V1 only. So V1, it will be V1a plus V1b, that is V1 only, that is equals to the summation of H11 plus H12. Sorry, not H, sorry, summation of H11a plus H11b. So it will be H11a plus H11b into I1 plus H12a plus H12b. H12a plus H12b, okay, into V2, into V2. And in the other equation, so this is what, this is basically my first equation, and in the other equation, that is, if I add my 2 and 4, okay, if I add my 2 and 4, this will be I2a plus I2b, I2a plus I2b, this will be equals to addition, like I2, what is the addition of I2a and I2b? It is I2 only. So this will be I2 that is equals to H21a plus H21b. So H21a plus H21b into I1 plus H22a plus H22b into V2. Okay, so ultimately from here we get the values. So like from here, right, you can directly say that your overall H parameter of the network will be the individual sum of HA and HB, H parameters of the individual network. Why I also have explained, right, what are the dependent variables and independent variables. So like this one, you try it out by yourself, you just check which one is dependent, which one is independent, you write down the values, and I will just pause the video and write down all the values, because that will just waste your time. This is similar to the previous one, so I want you to try this one by yourself, and after a pause I will come back with the like all the solutions. So I have written the relationships for the parallel series connection. So in parallel series, the input side is parallelly connected. So V1 is same as V1a and V1 is same as V1b. Okay, so that is a parallel connection, and my like V2 is the series combination of V2a and V2b. Okay, it is the sum. So V2 port 2 is the series connection, because I2 and I2a is in the same series. Then again, this is coming back here where my I2a is equals to I2b and I2b is equals to I2. So that's why the port 2 is in series, and port 1, I hope you can see, it is in parallel. So if the input side is parallel, that means like what thing is common? So V1 is constant for the input side and I2 is constant for the output side. So here my independent variables will be V1 and I2, which is for the G parameters. For the G parameters, the independent variables are V1 and I2. So I have done the same thing. I have written down the equations, and then if I add the two equations, right, I will get this value. So basically ultimately G matrix will be the combination of GA plus GB. Okay, this was pretty simple, like similar analysis like the previous ones. Now let's come to the cascade connection. So cascade connection is very interesting. So cascade means basically one two-port network is there, with it another network is cascaded. Okay, so its input is connected to the output of the other network. So cascade means input is connected to the output of the other network. Then what happens? Then simple product happens. Product of what? Product of the two ABCD parameter matrix. Simple product of two ABCD parameter matrix. So how is it possible? So what are constant here? If you understand that my V1 is equals to V1A, you can directly see the input side, right? And my I1 equals to I1A. So input size, input, like for the network A, input is same as the voltage and current. Okay. Also one more thing is that in between here, if I see that my V2A is equals to V1B. Okay, this is just a parallel connection. So V2A is equals to V1B, and my I1B is equals to minus I2A. Okay, I1B equals to minus I2A, and for network B, V2B is equals to V2, right? V2B equals to V2. So these are the equations that I know, and my I2B equals to I2 itself. Same direction, right? I2B is here, I2 is also here. So they are just in the same direction. Okay. So yeah, this is the case. So like I have just written down the equations. You can see the equations, but we will not use the equations now. We will use the matrix. So matrix for the network A is written here, and matrix for network B is written. So this network A, right, can be rewritten. If I just copy and paste this whole thing, if I just copy and paste this whole thing here, like my V1A is what? V1A is simple V1, right? V1A is simple V1, and I1A is simple I1. So this can be changed here. Also, this V2A is what? V2A, I have written it here. V2A is V1B. So this can be changed to V1B and I1A. And right, I1B is negative of I2A. I1B is negative of I2A because they are in opposite directions. So basically I1B will be negative of I2A. That means here an extra negative sign will be there, right? So because minus sign is already there from here, and I2A will be replaced with negative of I1B. So minus minus will become plus. So this is what? This is V1B, I1B. So V1B into I1B is equals to this matrix, correct? Is equals to this matrix. So I can directly change. I can put the value of V1B and I1B here. Okay. So ultimately my equation will become V1 I1 equals to AA, BA, CA, DA is already there. Like this portion will be there, right? And this one I will replace with this one. Okay, V1B and I1B is this one, right? So it will be AB, BB, CB, and DB. And this one will be V2B and I2B. So what is V2B and I2B? So here, right, if I replace this whole, if I copy this whole thing, what is V2B and I2B? So V2B and I2B from the first page, V2B is V2, I2B is I2. So this will be V2 and this will be minus of I2, correct? Because both of them are same. Okay, so this is V2 and this is minus of I2. So ultimately, right, overall this is what? This is TA matrix, this is TB matrix. So ultimately I get this relation that V1 I1 equals to TA into TB. This we have used in the previous lecture, not in in the previous lecture as well, right, where I was multiplying two cascade networks. This I have used in the previous lecture. So this will be equals to V2 minus I2. So this value comes out to be what? TA into TB. TA into TB is there. So TA into TB is there. So this value comes out to be like ultimately, right? My overall T parameter matrix is TA into TB, because this relation between V1, the input port, and the output port is just for the transmission parameter matrix. So it will be TA into TB, hence proved. Okay, so I hope you have understood how cascading works and all those things. So this was the clear explanation. So summary is written over here. Whatever we have discussed, the same thing is written over here. Now let's solve few questions. So this is the first question. We have to find out the ABCD parameters. So there are two ways to go about this problem. One way is, like, multiple ways you can find out. Okay, so one way is using Z parameter. Okay, so I will solve using all the methods. So method one is using Z parameter. Using Z parameter. So let's simply write the input and output KVL equations, because like Z parameter is very good for the star network, right? So that's why we can use the Z parameter. So if I write the input KVL, so it will be V1 will be equals to I1. So if I copy the network, right, this current will be what? I1 plus I2. Okay, so V1 will be equals to I1 plus I2 into 3, of course, plus I1 into 1 is there. So this will be overall 4I1 plus 3I2. 3I2. Also, one more thing I wanted to mention, like this is the last lecture, so I wanted to mention that if you ever calculate Z parameters, right, of a purely resistive network or a passive network. So I want to say one key point, that after calculating the two port parameters of a passive network, make sure to check the condition of reciprocity. Why? Because you might have done some mistake, right? You might have done some mistake while calculating the parameters. So if you check the condition of reciprocity, if your equations are actually satisfying the condition of reciprocity, so whatever you have calculated is actually correct. So that is a way to check your calculations, so that you have bit of peace in your mind that whatever you have calculated is correct. You have that peace in your mind. So that is the only thing that I wanted to say to you. So yeah, this is my V1 basically, and what about V2? So V2 will be equals to 3 into I1 plus I2 plus 2I2. So V2 will be equals to 3I1 plus 5I2. So these are my Z parameters, where I check that of course my Z12 equals to Z21, so hence it is a reciprocal network. So whatever I have calculated is correct. There is nothing wrong. So I need to find out the ABCD parameters of this network. How do you find out the ABCD parameter? What is A? So let me first write down the equation, right, of ABCD parameters. It is AV2 minus BI2, and my I1 is CV2 minus DI2. Okay, so my A equals to V1 by V2 when my I2 current is 0. So if I make my I2 current, so another relation is there, that my C is equals to I1 divided by V2 when my I2 current is 0. So if I make my I2 current 0, so this goes away, right? So basically this equation can be modified. This V1, this equation, and the next equation. So this equation and this equation will be modified here. So if I2 is 0, right, ultimately this gets converted into V1 equals to 4I1 and V2 equals to 3I1. So your V1 by V2 becomes what? 4I1 divided by 3I1. So it is 4 by 3. Okay. And your C is I1 by V2. So it will be 1 by 3. 1 by 3. Okay. What about the next parameters? That is the B and the D parameter. Okay. So B is, again, if I see from the equation, B is basically V1 by minus V1 by I2. So minus V1 by I2, that is my V2 equal to 0, at V2 equal to 0, and my D is my minus I1 by I2. D is minus I1 by I2, 1 by V2 is equals to 0. Okay. So this is equals to, so minus V1 by I2 minus V1 by I2, right? So again I have to, in this equation I have to make V2 0 now. If I make V2 0, so basically this will be 0 equals to 3I1 plus 5I2. So from here I can directly say my minus I1 divided by I2 will be equals to minus, it will be simply 5 by 3. Okay, because negative sign I have already taken into account. So it will be simply 5 by 3. So this value will be 5 by 3. What about V1 by I2? So if this is 0, right? So now I can replace my I1 as minus 5 by 3. So this equation will be V1 equals to 4I1 minus 5 by 3 into 3. So this will be minus 5I1. Okay. So yeah, this will be minus 5I1. Anything I'm making a mistake? Negative 5 by 3 minus. Okay. Okay. Sorry, I have to write I2, right? I don't have to write in terms of I1. Sorry. So my I1 is equals to what? I1 equals to minus 3 by 5 I2. So this, right, will be 4 into minus 3 by 5 I2 plus 3 into I2. Okay. So this value will be equals to, I'll just quickly calculate this value. Okay. So this is 4 minus 12 by 5 V1 equals to, just let me quickly check whether I'm doing, like, whether I'm not doing any mistake, right? I1 will be here. Okay. I2 5 by 3, yes, correct. Okay. 3 by 5. Okay. So this will be minus 12 plus 15 divided by 5 I2. So from here, right, actually my V1 by I2 comes out to be minus 3 by 5. Something is wrong, because like I have solved the question. This is not correct. So somewhere I'm making a mistake. That is what I'm trying to identify, where I'm making the mistake. Okay. For A1, because all the other parameters are, I think all the other parameters, I guess, are fine. Just this one is wrong. So where am I making the mistake? That is what I'm trying to identify. 4 by 3, this is okay. So here, if V2 is 0, right, if V2 is 0, so my I1 by 2 is minus 5 by 3. This is correct. Okay. So I2, so I1 is equals to, oh sorry, what am I doing? I'm sorry, I1 is equals to, that is what I was thinking, right? I1 equals to minus 5 by 3. So this will be opposite, right? Minus 5 by 3. So this will be minus 20 plus 3. So minus 20 plus 9. Minus 20 plus 9. So this will be minus 11 by 3. Okay. But I have to write minus of V1 by I2 because there is a negative sign here, that's why. So minus of minus 11 by 3 will be 11 by 3. Okay, so this will be ohms. So this will be your answer. Basically your ABCD matrix will be ABCD matrix will be 4 by 3, 1 by 3, 4 by 3, 1 by 3, minus 11 by 3, and 5 by 3. Sorry, plus 5 by 3 and 5 by 3. You can cross verify this. You can check the condition for the reciprocity. So determinant of t must be equals to 1. So here if I find out determinant of t, that is here 20 by 3 minus 11, not 3, sorry, 20 by 9 minus 11 by 9, that is 9 by 9, that is equals to 1. So of course it is satisfying. So whatever we have calculated is correct. Okay. Now is there any other way to solve? Of course there is other ways to solve this question. So method 2 is using cascaded formula, right? Method 2 is cascade networks. So what we can do, I have already told you one thing. What have I told you? So I have told you that if I just copy this network, so what I can tell you is that uh, this is network A and this is network B. So we have already discussed in the previous lecture the ABCD parameters for network A. So this is what, so if you remember, first I would have written here like 1, and this unit was what? This was unit of ohms, because here I had I2 and in here I had V1, right? So V1 by I2. So here I had unit of ohms which is in here, right? So that's why this will be the value here. So this was let's name this as Z1, let's name this as Z2. So here Z1 was there, here 1 by Z2 was there if you remember, and here a simple 1 was there, right, at the end D, and here it was plus the ratio of these two, Z1 divided by Z2. So Z1 divided by Z2. I told you as well how can you remember this formula. So this will be actually very useful to you if you remember. Okay. So from here I can directly write the ABCD parameters of network A. So ABCD parameters of network A is 1 plus Z1 divided by Z2. Z1 is 1 ohm, Z2 is 3 ohms. So it will be 1 by 3 and Z1 is 1 ohms. 1 by Z2 is 1 by 3 again in 1. Okay. So this is the ABCD parameter of network A. What is the ABCD parameter of network B? It is just a simple series element. So use the same formula. Use the same formula. How can you use the same formula? So network B, right? I can write it like this. This is 2 ohms and this is open circuit. Okay. So what I can say that my ZB or Z2 is infinity in this case, because I have infinite infinity. It is sorry, I have infinite impedance. I have infinite impedance. So that is what Z2 is. This is my Z1. Okay. So use the same formula. It will work. It will not break. It will totally work. So it was 1 plus Z1 divided by Z2. Z1 divided by Z2. So Z2 is infinity, right? So anything finite divided by infinity is 0 only. And here I have Z1. So Z1 is 2. Here I have 1 by Z2, that is finite upon infinity is 0 again. This will be 1 only. So this will be equals to 1 to 0 1. Okay, that's how good this method is, right? Now what you need to do is simply use the cascade formula. So overall net ABCD parameter of the network will be TA into TV. So it will be 4 by 3. This is 4 by 3, 1, 4 by 3, 1, 1 by 3 and 1, I guess. Yes. And this will be 1 to 1 to 0 1. Okay, so my T parameter will be equals to 4 by 3 into 0. So 4 by 3 into 0, this is 8 by 3 plus 1, and this will be 1 by 3 into 0, so 1 by 3, and this will be 2 by 3 plus 1, so 5 by 3. Isn't this the one that we derived with the previous method? So 4, okay, something is wrong. This should not be 4 only, right? This should be 4 by 3. Yeah, actually it was 4 by 3. Sorry, this is 4 by 3. So this is 4 by 3. What have I done? Okay, I forgot to like write the 4 by 3 here, right? Sorry, I'm sorry, I forgot to write the 4 by 3 here. So like if you see 4 by 3, 11 by 3, 1 by 3, 5 by 3, 4 by 3, 11 by 3, 1 by 3, 5 by 3. So like this also you can solve. Okay, so or if you want to like break it even further, right, you can break it, like you can just calculate the ABCD parameter for this network, calculate the ABCD parameter for this network, calculate the ABCD parameter for this network. So that is the homework for you. Like you will get the same result, but I want you to have practice. So what is like the extension of this method? Method 2 dash is just break it even further, right? So this one will be network A, and I will break it even further in 3 networks. Okay, in 3 networks I will break it. This one will be network B, and this one will be network C. Okay, so here in the first case, in the first network, for network A, the Z1 will be 1 ohm, but Z2 will be infinity. Okay, for network B, the Z1 will be 0 ohms, the Z2 will be whatever finite value they have given, that is 3 ohms. For network C, that is the homework, you will do this by yourself. Network C, the Z1 will be again series combination 2 ohms, again the Z2 will be infinity. Okay, so basically ultimately you will find the individual ABCD parameters, then you will simply do the matrix multiplication, network A into network B into network C, and that's it. That's basically it. Okay, and you will find out your result. So this is how also you can solve. This is the homework task for you. You will try it out by yourself. Now let's come to the next question. So if I have like this matrix is given, and we have to find out the ABCD parameter of the following network. So basically they're asking ABCD parameter of the whole network. So seems simple, right? So I have the ABCD parameter of this network. Okay, oh sorry, I have the, okay, I have the ABCD parameter, sorry, actually here the question should be ABCD parameter of the linear network. For the linear network, if ABCD, if the matrix relation is shown below. So basically right, so I'll just copy this question on my assignment as well, like else there will be a bit of confusion. Where is the assignment? Yeah, here, not this one right here. So actually what they have given me is that they have given me the ABCD parameter of the whole network, because this is V1 I1, that is the outside port, this is V2 minus I2, that is the outside port. So ABCD parameter of the whole network is given, but they are asking me ABCD parameter of the this network, right? So basically what is this? This is just simple cascade connection. So I can directly say that ABCD parameter of the whole network will be equals to the cascade of network A TA into TB, correct? TA into TB. So I can write this network as a combination of two networks. Okay, so this will be network A into network B. Okay, so it is TA into TB. So now what I can write is I need TA, right? So how do I find out TA? TA can be found out if I take the inverse, if I post multiply the inverse of TB. So it will be equals to T into TB inverse, correct? So that is what we have to do. So first of all, I need to, like, T is overall given, right? This is my T matrix. T matrix is this. I just need TB. So what is TB? TB is very, very simple, right? Of course you can solve it, that is up to you, but we already remember the formula. So this is equals to 1, like this will be helpful in power systems as well, so I will recommend you remember the formula. Okay, this formula, this will be helpful in power systems as well. So this will be 1 plus uh, the z2 z1 upon z2, this is z2 by 1 by z2 1. So this will be 1 2 2 1 by 2 1. Okay, now I have to find out TB inverse. So TB inverse will be basically swapping of the main diagonal elements, minus 2 minus 1 by 2, and of course dividing by the determinant, right? So 2 into minus 1, that is 1, determinant will obviously be 1, it is a reciprocal network, determinant will always be 1. Okay, so this is the TB. So I need T, right? T will be what? T will be, sorry, TA will be T into TB inverse. So what is T? T is 3211 211, and TB inverse is 1 minus 2 minus 1 by 2 2. Okay, so TA will be equals to 3 minus 1, 3 minus 1, that is 2, minus 6 plus 4, so minus 2, minus 6 plus 4, then 1 minus half, so it will be half, then minus 2 plus 2, this will be 0. Okay, so 2 minus 2 0, this will be the answer basically. 2 minus 2 half 0, this will be the answer. Okay, so again you can cross verify that what is the overall impedance, because individually, like, if you see this network, right, this network is reciprocal actually, reciprocal. Why? You can check with the uh, you can check with the determinant condition. This is equals to 1. Okay, this network is also reciprocal, right? It will always be, it only consists resistive elements. So this also TB determinant is also equals to 1, delta 1 is also equals to 1. So one more key point I want to say here is that if two reciprocal networks are cascaded together, then the overall network also will be cascaded. Okay, overall network also will be cascaded. So that is one thing, yeah, that you have to keep in mind. Okay, so yeah, yeah, that is just one thing that we have to keep in mind. Okay, yeah, I think, yeah, that is just, that's it. Those are the points that I wanted to say, key points. This is my key point. Okay, so yeah, yeah, that's it. So now let's come to the transformer portion. So one more thing I just wanted to say is that, like, I was thinking whether I should say that point or not. Basically, if your network is individually symmetrical, right, then the overall network also will be symmetrical. Got it? So if, like, same thing, if two networks are symmetrical, then the individual network will also be symmetrical. If two networks are symmetrical, then overall network also will be, sorry, will be reciprocal. I should have written here reciprocal. it will be symmetrical. Okay, so yeah, that's it basically about the symmetricity condition. Now you might have a doubt, what if out of the two networks one is reciprocal, other one is not reciprocal? Will the overall network be reciprocal? We cannot comment. So that I will also write here, that another key point, if one or none of the network are reciprocal is slash are reciprocal, we cannot comment, we cannot comment whether the whole network will be reciprocal or not. Okay, so we cannot comment about this actually, so it depends on how the combination is, how it is behaving, so we cannot comment. But this much I can definitely comment, if all the networks are reciprocal individually, the overall network also will be reciprocal. If all the networks are symmetrical individually, the reciprocal network will also be symmetrical. Sorry, the overall network will also be symmetrical. Now let's understand a bit about transformers. We have discussed about transformers. So transformer is actually a reciprocal network. Why? Because if you give some excitation here, same type of current you will get here, right? So it is a reciprocal network. This you can verify with the ABCD parameters. Okay, this you can verify with the ABCD parameters, but for a transformer the Z and Y parameter does not exist. Okay, Z and Y parameter does not exist. So we can find out other parameters like H parameter and ABCD parameter. G parameter is for you. So I will write down the each parameter for transformer. So what is H parameter? So each parameter, this will be basically a equation of H is V1 here, then I have H11 I1 plus H12 V2, then I2 here, H21 I1 plus H22 V2. Okay, so from here I can directly write few things, right? So what is H11? H11 is V1 divided by I1 when my V2 is 0, and H21 is I1 divided by I2, sorry, it is I2 divided by I1 when my V2 is 0. So if V2 is 0, it does not matter, right? So V1 by I1 will be what? If V2 is 0, V1 by I1 will be what? So what is V1 by I1? So if V2 is 0, right? If V2 is 0, V1 is also 0, correct? So what is the relationship between the currents of a transformer? So the current, remember, the current across the transformer is this, right? Current across the transformer is this. Don't mess up. Current across the transformer is this actually, I2 dash. This is the actual transformer. So if I write the turns ratio equation, so V1 divided by V2 will be equals to 1 by n, and I1 divided by I2 will be equals to, okay, this is wrong, right? I have to make I2 dash because transformer is with respect to I2 dash. This will be opposite of the turns ratio. So this will be n by 1. This will be n by 1. But of course, my I2 dash equals to minus I2, right? Because I2 dash is in this direction, I2 is in this direction. So both are opposite. So from here I can directly say that my I1 over I2 minus I2 will be equals to n, or I1 divided by I2 will be equals to minus of n. Okay, so from here I can directly find out the values. Okay, so what will be my H11? What will be my H11? H11 will be equals to V1 by I1. H11 will be equals to V1 by I1. So V1, okay, so when V2 is 0, if V2 is 0, right, if this is sorted, of course V1 also will be 0, because if I'm not giving any voltage here, it is just a linear multiplication of the other voltage, right? So V1 equals to what? V1 equals to V2 by N. So if V2 is 0, V1 will also be 0. So it will be something 0 upon some finite value. I don't care whatever the value of current is, it is not 0. That much I am sure, it is not 0. If it is not 0, then 0 upon finite value will always yield me 0 ohms. What about H21? H21, again V2 is 0. If V2 is 0, right, I don't care. I have to find out the ratio of I2 by I1. So I2 by I1, the ratio already I know. We don't care about any condition. For any condition, ratio of I2 by I1 will be minus of n. So this will be minus of n. Now let's calculate the other two parameters. So it is H H12, that is equals to V1 divided by I2, that is equals to I1 equal to 0. So V1 divided by I2, I1 equals to 0. So it will be okay. So if I1 is 0, right? Sorry, not I1 0. Sorry, not I1 0. Oh yeah, I1 is 0 only, right? V1 divided by V1 divided by V2. V1 divided by V2, and H22 is I2 divided by V2 when my I1 is equals to 0. So I can directly say here that my what can I say that my this, right? So V1 divided by V2 is unconditional, right? V1 divided by V2 is always 1 by n. Okay, so V1 divided by V2 is always 1 by n, correct? V1 divided by V2 is always, okay, is it always, again am I making a mistake? It is V1 divided by V2, okay, and this one was I2 divided by I1. Okay, sorry, this was I1 divided by I2, right? So I2 divided by I1 will be just the reciprocal, so this will be just the reciprocal 1 by n, and here I have to write V1 divided by V2. V1 divided by V2 is 1 by n, so this will be 1 by n, and H22 is I2 upon V2. So if I1 is 0, right, if I1 is 0, then I2 will also be 0. Same reason, right? Same reason as voltage. So if I1 is 0, I2 will also be 0. So it will be something 0 upon any non-zero number. V2 will be any non-zero number. So what will happen is this will ultimately be 0. Okay. So my H parameters matrix is 0, 0, and this is 1 by n, sorry, minus 1 by n, and this is 1 by n. Sorry, this is plus 1 by n and this is minus 1 by n, correct? So what I observe is that my H12 is equals to minus of H21. H12 equals to minus of H21, and my H, like determinant of the matrix H, is equals to some value 1 by n square. Okay, so it is not always symmetrical. It will be only like determinant of H has to be equals to 1 for it to be symmetrical. This is the condition for reciprocity. So it is a reciprocal condition. It is always reciprocal network. So transformer is a reciprocal network. But for symmetricity, right, for symmetricity this has to be equals to 1, right? How it will be equals to 1? If n square equals to 1, that is if n is equals to 1, n cannot be negative 1, n has to be equals to positive 1. So if n is positive 1, then my network will be symmetrical. Okay, so what I can say is that my what else can I comment? I can comment that about G parameters. So how will you find out the G parameters? So G parameters will be equals to like G1, like it will be just the inverse of H parameter, right? G parameters will just be the inverse of H parameters. Okay, very simple and easy to understand. So what about the ABCD parameters? What about the ABCD parameters? So let's calculate the ABCD parameters. So if I want to calculate the ABCD parameters, so now I will calculate the ABCD parameters. So the ABCD parameters, I will copy this whole thing because this will be required anyways. This will be what? This will be equals to, so I can directly say here, like what is the equation of ABCD parameters? My V1 is equals to A V2 minus B I2, and my I1 is equals to A C V2 minus D I2. So I can directly say here, I can directly say about what is my A? A is V1 by V2 when my I2 is 0. So I don't care, of course V1 by V2 is independent, it is always 1 by n. Okay, and my C is I1 by V2 when my I2 is 0. Again, if I2 is 0, right, basically this is 0 upon some finite value, so this will be 0 only, correct? So C and A are found out. What about the other parameters? The other parameters, if I want to find out, that is B. B will be minus of V1 by I2, minus of V1 by I2 when my V2 is 0. So if my V2 is 0, if my V2 is 0, it will be equals to V1 by 2 if my V2 is 0. If my V2 is 0, if my V2 is 0, if my V2 is 0, that means V1 will also be 0. So it will be finite upon 0 upon non-zero, so it will be 0 only. C will be minus of I1 upon I2, minus of I1 upon I2, minus of I1 upon I2 is simply positive n, right? Positive n, unconditional. It does not matter if V2 is 0 or not 0, it is unconditional. So from here, if I write down the matrix, my ABCD matrix, right, of transformer, A is 1 by n, A is 1 by n, B is 0, and my C is 0, and my, sorry, C is n. Okay, sorry, hold on a second. B is 0, okay, A is 1 by n, and okay, I made a mistake. Sorry, this is not C, right? This is D. Sorry, this is D. C is 0 only. C is 0 only, and D is n. So if I check the reciprocity condition, right? What is the reciprocity condition? Reciprocity condition is determinant of T. Determinant of T is here 1 by n into n minus of 0. So it will be 1. So determinant is 1. So hence network is reciprocal as proved in the previous iteration as well. And is it symmetrical? No, right? My A is not equals to D, hence the network is not symmetrical. It will be symmetrical if my n is equals to 1. Same condition, right? If here n is equals to 1, if n is equals to 1, then network will be symmetrical. Then network will be symmetrical. Okay, so yeah, I hope you have got the point. So now let's solve few questions. So we have to find out the y parameters for this network. So at first glance you will say, sir, y parameters does not exist, but just see the network, right? Here I have a resistor. So if I make any changes in the transformer, right, then the y parameters can exist. You have to check y parameters can exist for that network. Okay, so you can simply use the simple basic transformer relation. So if I copy this, right, I have to find out the y parameters. So this is my I1, this is my I2 dash, this is my pore current I2, and this is voltage V1, this is voltage V2. This is the transformer voltage V2 dash, this is the transformer voltage V1 dash. Okay, so bit of differences are there, right? So one thing I know, the transformer relation. So what is the transformer relation? V1 dash divide by, so this is the method 1, using basic transformer property. Using basic transformer property. Okay, so V1 upon V2 dash. Okay, so internal voltages are related, right? Not the external voltage. Remember, the internal voltages are related, not the external voltage, right? So external voltage can be different, but the relation between internal voltage is there with respect to the turns ratio. So V1 dash by V2 dash will be turns on the primary side divided by the turns on the secondary side, and my current, right, I1 dash divided by I2 dash will be equals to, so this is my I1 dash and this is my I1 current, will be equals to opposite turns ratio 1 by 2. So one thing I can say is this is equals to, like, V2 dash and V2 are same, V2 dash and V2 are same. Also my I2 dash and I2 are negative, my I1 dash and I1 are same. Okay, these things are same, other things are different. So here I can replace V1 dash will be V1 dash only, my V2 can be replaced with V2. Here I can replace my I1 dash to be equals to I1 and my I2 dash to be equals to minus I2. So this will be 1 by 2. So I1 will be equals to I1 by I2 will be equals to minus of 1 by 2. I1 by I2 will be equals to minus of 1 by 2. That's it. Okay, so I hope you have understood this basic point. So now what we can say is we can write the equation. So what is my y11? Y11 is basically I1 upon V1, right? 1 by V2 is 0. So if my V2 is 0 now, is V1 also 0? No, right? There is no direct relationship between V1 and V2, right? There is no direct relationship between V1 and V2. So if I make V2 0, then this voltage here is 0. So if V2 is 0, right, that means my V1 dash is 0. And one thing I can write, that this current, right, this current I1, I can write a KVL across this current, right? So I1 current will be equals to V1 minus V1 dash divided by 2, the resistance between them and the voltage between these 2 points. So if V2 is 0, that means V1 dash is 0, that means this is 0. So I1 will be V1 divided by 2. So I1 by V1 will be 1 by 2. So from here I can get my value of y11, that is 1 by 2. Very simple and easy to understand. Okay, very simple and easy to understand. What about y12? Y12 is I1 upon V2. Okay, y12 is I1 upon V2 when my V1 is 0. So let's first solve for the y21 only. It is I2 upon V1 when my V2 is 0. So what is the I2 current? So I already know like this relation, right? This relation. So I1 is equals to what? So from here I can directly write what is my I1. I1 is equals to minus of I2 divided by 2. I1 equals to minus of I2 divided by 2. So I1 equals to minus of I2 divided by 2. So this will be minus of I2 divided by 2. If I replace this equation, right? This equation if I replace minus of I2 divided by 2. So here this will become minus of I2 divided by 2V1 equals to 1 by 2. So I2 divided by V1 equals to minus of 1. Okay, minus of 1. So from here this will be minus 1. This will be minus 1 value. Okay, this will be minus 1 value. So y21 is minus 1. Now let's calculate the y12. Y12 is I1 by V2. So V1 is 0. So this time I will make the input to be 0. If input is 0, right? If input is 0, I can now calculate the current. So what will be the current? Current will be I1 will be 0 minus v1 dash divided by 2, correct? So I1 is equals to, now what is v1 dash? So v1 dash, right, is equals to, if I write here v1 dash equals to 2 into v2, so v1 dash equals to 2 into v2, so I can write here that my v1 dash equals to 2 into v2, so I can replace here my this will be minus 2 v2 divided by 2, so my I1 will be minus v2, okay? So this will be my I1 basically, this will be my I1. So so basically my I1 by v2 is this, so I1 by v2 is minus 1, I1 by v2 is minus 1, so this will be minus 1, okay? What about y22? Y22 will be I2 by v2, I2 by v2 when v1 is 0. So so I know what is my I1 equals to, right? I think what is my I1 equals to, so I1 equals to minus I2 by 2, right? So I can replace here, right? I can replace I1 as minus I2 by 2. So if I replace from this equation, why is it not going up? Why is it not going up? So here, if I replace I1 with minus I2 divided by 2v2 equals to minus of 1. So this will be I2 divided by 2 equals to 1. Okay. So sorry, equals to 2. So I2 divided by V2 will be 2. So Y22 will be 2 simply. Okay. So like this you can simply calculate the Y parameters. Okay. So what will be the Y parameters? Y parameters will be, my Y11 will be minus 1. Okay. Sorry, Y11 will be half. Y11 will be half. Y12 will be minus of 1. Okay. Y21 also will be minus of 1, and y22 will be half. Okay, so if you just verify, right, it is like either it consists of a resistor and a transformer, both are reciprocal, so overall also the network should be reciprocal, which I am able to see that my y12 is equals to y21. If y12 is equals to y21, that means the network is reciprocal. So this is how you can cross verify that whether whatever you have solved is correct or not, whatever you have solved is correct or not. This is how you can cross verify. Okay, so method 2 is there, that I will leave it to you. Okay, what is the method 2? Method 2 is very simple actually. What you have to do is you just have to simply multiply. So you have to find out the t parameter. So this network, right, I can divide into two networks, cascade combination of two networks. So that is what I am leaving it up to you. So this is the cascade combination of two networks. So this is my, like, this is my network B transformer, this is my network A. Okay, so obviously the overall t parameter you find out, that is TA into TB, and from the T network you can obviously write down the T parameter equation, you convert to Y parameter equation. Okay, this will be bit lengthy, better approach I have already discussed. Okay, so yeah, let's solve one more question. Okay, I guess this is the last question. So a lot of things are there. So here, right, actually this approach will be used, because I can divide the network. So this actually came in gate examination, so this is a good question. Okay, this is a good question actually. So what we can do is, we can actually break this network. So we can break it down to here and here. Okay, three networks. So this is one of the network, this is the other network. Okay, so this is my network A, this is my network B, this is my network C. Okay, I cannot actually, no, this is not my standard network, right? This is not my standard network. Okay. So I have to break it into 5 networks actually, sorry. So I have to break it down into 5 networks. Of course, you can individually calculate. So method 1 is, I will tell you about the method 1. So method 1 is simply, as the network is very weak, calculate the parameters individually, which will be better actually. Calculate the parameters individually because they have only asked for parameter A. As they have only asked for parameter A, so this method will also be good only individually. Okay, so I have to find out A. What is A? So if I write down the equation, my V1 equals to A V2 plus, sorry, minus BI2. So my A is equals to V1 divided by V2 into I2 equals to 0. Okay, so if I make I2 0, basically this means this is open circuit, right? I2 0 means this is open circuit, so no current is flowing, so this V2 is coming across here. So if I copy the circuit, if I just copy this circuit, so I2 is 0, right? I2 is 0. So if I2 is 0, that means there is no drop in this resistor. So whatever the voltage is here, same voltage is here. So it will be plus minus V2. And what is the current here? So current across the voltage I know across the resistor, current will be V2 by 5. Voltage divided by the resistance. So this current is V2 by 5. Okay. So I know this current. So what will be this current? So it's just turns ratio, right? So it is 1:2. So here voltage is getting doubled if I'm going from primary to secondary. Now if I go from secondary to primary, current will be doubled, just the reverse relation. So current will be doubled here. So this current will be 2V1 2V2 divided by 5, and this voltage is what? Voltage across the resistor is V1. So current through the resistor will be V1 divided by 5. So what is I1? Do I need I1 actually? Okay, so this voltage is V2, right? So if this voltage is V2, what is this voltage? So if I go from primary to secondary, voltage doubles. If I go from secondary to primary, voltage should be halved. So this will be V2 divided by 2. So I can simply apply a KVL here. So this will be minus of V1 plus the drop across this. What is the current? Current is 2V1 V2 by 5. Current is 2V2 by 5. So 2V2 by 5 into 2. So direction also I have taken correct only. So this is the direction. So drop will be plus minus. Then this is plus V2 by 2 plus V2 by 2 equal to 0. So from here this will be V1 V1 will be 4 by 5 and 4 by 5, and this if I multiply by 5, this, so this will be 14 V2 by 10. Okay, so your V1 by V2 will be I'm just checking whether I'm making any mistake or not. V2 is here. Okay, V2 by 5 is here. Here 2V2, sorry, here V1 by 5 is here. Okay, so what will be this current? This voltage will be 2 times that, 2V1. Yes, this is V2 by 5. Okay, fine. If this is V2 by 5, this will be 2V2 by 5. This drop will be 4V2 by 5. So 4 into 2, that is 8. 8 plus, sorry, 8 plus 5. 8 plus 5 is 13. Sorry, 13 by 10. So V1 by V2 will be equals to 1.3. This is my A, right? When my I2 is 0. So like this you can directly calculate. Okay, the easier one. Of course you can calculate the other parameters as well, but there is another way as well. Okay, so like you can convert this into individual networks. So I will give you as homework. So this you convert into individual network. Okay, like a shunt element, I have told you how you can convert a shunt element to a individual network. Then this last series element also you can convert to a individual network as well. So there will be 5 networks here. So this will be my network A, this will be my network B, this will be my network C, and this will be my network D, this will be my network E. So basically ultimately, right, two port parameters I have derived for a transformer, I have already derived, so you can use the formula. So ultimately your overall two port net parameter will be TA into TB into TC into TD into TE. Okay, just one important point is don't mess up the sequence. Okay, don't mess up the sequence of multiplication. So one key point is that don't mess up the sequence of multiplication. Okay, don't mess up the sequence of multiplication. So just be careful here. So now because like if you mess up, right, answer will come wrong. So this method is useful. So this is the method to basically cascading. This method is useful. Use this method if use this method if the ABCD parameters, all parameters are asked. Okay, all ABCD parameters. So if ABCD everything is asked, then you use this method. Okay, else it is not good approach, right? Because this is very lengthy, very lengthy. Okay, so that was about the transformer. Now there is one very small topic left about a gyrator. Okay, gyrator is just a device, just like a transformer. Gyrator is a device. So gyrator is a passive linear non-reciprocal network. So transformer was a passive linear reciprocal network, but gyrator is a non-linear network. Sorry, gyrator is a non-reciprocal network element. It converts voltage into current and vice versa. So let's say if I have a voltage here V1 and I1 current, right? So what will happen from here to here if I move? Okay, from left hand side to right hand side if I move, the like it will provide a resistance of RO. Okay, basically your V1 will be RO times I2. What do I mean by it is your V1, right, from the first equation, this V1 voltage source will see a impedance of RO. Okay, from here this V1 voltage source will see a impedance of RO, and that will be in terms of I2. Okay, that will be in terms of I2. So this much information just you have to keep in mind. Like two equations that you have to remember is V1, two equations, V1 equals to, generally, right, this will rarely get asked, and in gate examination also they will give you the equation. Don't worry, you don't have to remember the equation. In gate examination the equation will be given to you. V1 equals to minus RO into I2, and the other equation is V2 equals to RO into I1. So these are the two equations of a gyrator. Okay, this is just a device, and the device behavior is something like this. So voltage is in terms of current, that's it, in terms of the current of the other side, that's it. Okay, so that's why it is used for voltage to convert into current, or current to voltage, anything, right? That's it. So what are the parameters? So the Z parameters are very simple to understand, right? This is the underlying equation. So don't have to remember this. I hope most probably in the examination it will be given, the equation will be given, don't worry. Okay, so what are the Z parameters? So if I want to write the Z parameters of a gyrator, if I want to write the Z parameters of a gyrator, So here, right, z parameters is in terms of v1 equals to z11 I1. So z11 here is 0, of course. Z12 is minus of RO. Z21 is RO and Z22 is 0. Okay. So basically the Z matrix will be 0 minus of RO 0. So it is symmetrical. So Z11 equals to Z22. It is a symmetrical network, right? It is a symmetrical network, but it is not reciprocal, right? Why it is not reciprocal? Because my Z12 is not equals to Z1. Okay, Z12 is not equal to Z1, so hence it is not reciprocal. Okay. Y parameter, what about the Y parameter? So if I want to write the Y parameter, so I have to write the current in terms of voltage. So my equation will be flipped now. So I1 will be equals to 0 into V1 plus 1 by RO into V2, and I2 will be equals to 0 into V1 minus 1 by RO into V1. So okay, so this will be okay. So what I can say is, from here I can directly write my y11 will be 0, my y22 will be 0, my y12 will be 1 by RO, and my y21 will be minus 1 by RO. You could have done the inverse of this matrix as well. You could have got to the same result. Okay. So what will be the H parameters? So H parameters will not actually exist here. Okay. So I will write here H parameters and G parameter does not exist. Why? Why it does not exist? It does not exist because if you see that my v1 v1 okay, v1 is fine, my v2 is function of only I1, and these were supposed to be my independent variable for H parameter. And here my I2 is function of only v1. If you see here, my I2 is a function of only v1, right? So again here G parameter, right? So that's why, like, this was supposed to be the independent variable in G parameter and H parameter respectively. So of course they are not independent, they are dependent on each other. So of course G parameter and H parameter will not exist. What about ABCD parameter? Okay, so ABCD parameter again is simple. So ABCD parameter will take on one more page. So ABCD parameter will be basically ABCD parameter will be what? ABCD parameter will be what is the ABCD parameter? ABCD parameter here is my, what are the equations? Equation is v1 equals to a v2 minus bi2 and I1 equals to a equals to cv2 minus di2. Okay, so v1 equals to V1 equals to so I can say so I need the A, right? What will be A will be V1 by V2 when my I2 is 0. So if my I2 is 0, if I copy this equation, if my I2 is 0, then my V1 is automatically 0. Okay, so it does not matter whatever is my V2. If my I2 is 0, V1 is automatically 0, so A will be 0. Okay, what about C? C is also I1 divided by V2 when my I2 is 0. So it is I1 divided by V2, it is independent, right? I1 divided by V2 is independent, that is 1 by RO. 1 by RO. Okay, so I1 divided by V2 is independent, that is 1 by RO. What about D and A and B? So B is V1 divided by minus V1 divided by I2 when my V2 is 0. So if V2 is 0, right? If V2 is 0, it does not matter. V1 by I2 is minus of RO, minus of minus RO will be plus RO. And what about D? D is minus of I1 divided by I2 will be equals to so if when my V2 is 0, right? 0, right? So if V2 is 0, I1 will be also 0. So that means this will be 0. So ultimately this will be 0 only. D will be 0. So my ABCD matrix matrix ABCD matrix is 0 RO 1 by RO and 0. So if you see, the determinant of the matrix is actually minus 1. So it is not plus 1, right? If it was plus 1, then it would have been reciprocal, hence it is not reciprocal. But it is symmetrical. That I have seen from the previous parameters as well, right? That is my A is equals to D, that is equals to 0. So it is symmetrical. So this was all about the two-port network. So any random network, if they give you, main objective should be, you should, if from the given equations, you should be able to find out the parameters. Don't get scared by the fact what is a gyrator, what is a transformer. Just equation will be given and solve according to the equation, that's it. Don't get scared by this device. Okay, so yeah, that's basically it from my end for this lecture and for the whole network theory and AC analysis. So just a one small request from my end, if you did watch till the end, so make sure to first of all go into the first video of the AC analysis, because of course in the DC part a lot of people have watched, so we have updated the content and we have just uploaded this year only, so the views are lowered, so people might think that AC analysis is not that good, but I hope you understand to what level I have taught you. So if you are a dropper student, you will understand, right, how many new things you have learned from watching the whole lectures. Trust me. And if you have learned, you can put it in the comments below. So just one request, go into the first video of the AC analysis, that is the phasor diagram lecture 1, and comment down your whole review about the network theory whole course, and of course the AC analysis part also you can give a review. Okay, so that is a small request from my end. So I hope you have enjoyed this whole series. If you did, make sure to hit the like button, and I will see you in the next video. Until then, happy learning.